Okay, let me share my screen.
Doctor,
أيوة.
just to make sure the material for the quiz.
Well, this is the homework. This we said, as we said last time, either directly one question from the homework. It will be, because since it's going to be multiple choice, so it's going to be more than one part. Okay. So either it's going to be from the homework or something similar within the homework. It's not.
So it will not include, Doctor, the motors and the DC generators that we have covered last class and before the last class also.
It is whatever you have in the homework, the material in the homework. It's not outside the homework.
Okay, Doctor.
Okay. Okay. Now, what we want to do in this lecture, basically, we would like to give some MATLAB commands, because MATLAB is very important, and we should, you should be familiar with MATLAB. I'm sure last week, I think you started with the lab, and they gave certain MATLAB commands. After that, we would like to talk about block diagram reduction. That basically, suppose I have this block composed of many transfer functions. I would like to reduce the entire block into one block. That's basically, I want to reduce it into, let's say, C of S, R of S. So basically, I want to find C of S over R of S. This is basically what we want to do in this lecture. So hopefully by the end of the lecture, we will be able to reduce any block into a single transfer function. This is important because, sometimes you would like to see the direct relationship between, R and C, okay? It will give us more idea if you want to design or if you want to understand. It would be better to have, sometimes in certain situations, you would like to reduce it into a single block. Any question here? So this is basically the objective of this lecture. MATLAB command, block diagram reduction. Let me start with the MATLAB command. I'm sure some of the commands you already have taken. For example, if I have a polynomial, how do I represent the polynomial using MATLAB? So basically, I will map the polynomial into a matrix where the highest power will be the first element in the matrix. It's a row matrix, of course. I have, for example, in this polynomial, it's going to be 1, 3, 0, 4. If I want to calculate the root of the polynomial, you just use the command roots, and it will give you the roots of the polynomial. If you have the roots, you can go back to the polynomial by using the command poly. I don't know whether did you take this command?
Yes.
Okay.
Yes.
Yes, and more.
Okay. Well, if you want to multiply two polynomials,
Count. Yes.
I had 3s squared plus 2s plus 1 multiplied by s plus 4. Okay. I can define this one as the first system, let's say, call P, and call this is Q. And then take the command convolve P and Q. That will give you the multiplication. If you want to evaluate at a certain point also, you can, use also the this notation to give you the value of the polynomial. Well, one important command, if I have the transfer function of a system, if I have numerator and denominator, I can define in the system, I can define in MATLAB a system called, let's say, let me call it sys1, for example, TF okay, numerator and denominator. So if I have transfer function with the numerator and denominator, this is basically what you will feed. So the system will have an information, okay, about the system. Well, later on when we go to the state space, I could also do similar thing, but in there I will write SS rather than transfer function. So in here I'm defining the transfer function of the system. So suppose I have two transfer functions, this one and another one, G2, and I want to add them. So the addition simply sys, the overall system, equal to system 1 plus system 2. This is useful because, you know, later on, even in the block diagram reduction, you would like to reduce, if you have two systems in series, you would like to reduce them into one block. Any question here? Any question here? Okay. Now, let's talk about the block diagram model. What's the block diagram? We said we want to reduce it, but what's this block diagram?
A way to represent transfer function.
Or input-output relationship. Here we are going to the, you know, transfer function, the block diagram of transfer function, but in general, block diagram, it is, you know, a box where you have an input and output. But what's important, it has a direction. The signal has a direction. So that's basically, this is the transfer function of field-controlled DC motor. It relates the voltage in the field to the position, to theta. So what's important in here, the relationship, this is a unidirectional. So when you find theta of S over V of S, so directly it's going to be what's it equal to?
It will be equal to the reciprocal of the block vector.
Okay, exactly. But so I cannot reverse the direction.
Why the reciprocal, Dr. of the block? It will be the block itself.
It will be what?
The block.
No, but it's going to be, what I'm saying, you cannot put it this way, it will have different meaning.
Yeah, of course. If theta of S is the
so it is, you know, what I'm trying to say, it's a unidirectional. Okay, I cannot keep the same and find the relationship. It should be the inverse of that one. So basically, in any block, it has an input and output. Now, suppose I have a multivariable system. Let's suppose I have a system where I have two input and two outputs. In this case, the transfer function is going to be a matrix. Because look, I cannot say the ratio between the output and the input, because now the output is a column vector and the input also another column vector. I cannot divide a column by column. So usually if you have multi-input, multi-output, the transfer function will be written in this way. That's y of s equal to g of s r of s, where g of s is a matrix. It depends on how many output and how many input I have. In this question, or in this example, what's the dimension of the matrix G?
2 by 2.
It's going to be 2 by 2. I have two output, two input. The way I define, so basically I can write y of s equal to sorry, y1, let's say y2, r1 and r2. So I will have g11, g12, g21, g22. In general, gij, this will represent the I represent the output, the ith output, while the j represent the jth input. Okay. So if I use this matrix, what is y1 in terms of the r1 and r2?
It will be G11 multiplied by R1 plus G12 multiplied by R2. This is Y1.
Exactly. So this is basically what we have. And then Gij equal to the ith output, the jth input, equal to yi rj, setting all the rest equal to 0. All the input. So basically, in a way, I'm using superposition in order to find the individual elements of the matrix. I will be using superposition, that I will find, let's say, y1 in terms of r1, setting r2 equal to 0. And I can find y2 to r1 also by setting r2 equal to 0. And then go to the next level where you will get y1 over r2 and y2 over r2, setting r1 equal to 0. So this is basically what I'm trying to say in here. Okay. Now, the matrix is not necessarily a square matrix. Size of the matrix depend on how many input and how many outputs. Any question here? Any question?
Diagram on the right.
كيف؟
شو اسمه البوكس او الدياجرام on the right.
Yes, this one.
This is just
This is, it is, I'm combining them. I'm, putting this in, pictorial form that I'm relating. Okay, y1, look, suppose r2 equal to 0. Or no, look, what's y1 equal to from the diagram? Y1 equal to what?
yeah, we have R1 multiplied by G11 and also another from
R1,
R2.
R1, this one, I'm adding them, plus G12, okay, R2, isn't it?
So it's just a representation, a graphical representation of.
Yes, it's, it's 2 by 2, you can do it graphically, but suppose I have 3 by 3 or 4 by 4, then,
Go with the method.
To make it, I mean, you can visualize it. But once you go beyond the 2, it's going to be, I mean, this is the concept. I mean, you can, go to higher order, and the higher order, as I said, as I gave you, Gij equal to the ith output over the jth input, setting all the other inputs to 0. This is the way it will be.
We can also, Doctor, multiply by the inverse of the G, right?
You can multiply by the inverse.
Yes.
So what do you get? You want to get, you mean R?
Exactly, and then you simply
Okay.
have a direct relation.
Good. Wait. You can definitely. Suppose I have y equal, let's say, 1 over s plus 3. Okay. 0, 2 over s plus 7 minus 1 over s plus 2. How do you invert?
You cannot.
You cannot.
So you have to go with the superposition.
To find the individual. Yes, this is the way to do it. This is the way to do it. No, look, this, I mean, the relationship, the matrix, the multivariable relationship, y equal g of s, r of s, it is very general. It could be, g could be square or could be, you know, rectangular.
But if it's square matrix, I can use the idea of inverse, right? If it's a square matrix,
If it's square matrix, I can find what?
I can use the idea of inverse. It will be.
But what you know? No. What do you want to achieve if you use the idea of invert?
And for example,
What do you invert? Okay, wait. No. Abdurrahman, what do you want to invert?
The matrix G.
The matrix G, but you don't have the matrix G. What we are saying, this is the way to find the matrix G. This is the way I am defining my elements of G. So I don't know exactly, honestly speaking, I don't know what I'm trying to achieve. Sometimes, yes, sometimes in certain questions, you would like to obtain the input from the output. If you know the output and you know the transfer function, you invert. But in here, I want to find the elements G11, G12, G21, G22. So
and here we are interested in the characteristic matrices.
Exactly. I'm interested in the elements of the transfer function. And as I said, you can find them by using superposition from this relationship. Okay?
Doctor,
Follow.
I and J, what they are represent?
What? The I and J?
Yes.
Okay. They represent, suppose I have okay. This is okay. L1, R2, L2, C2. Okay. So, what are my inputs in the system?
V1 and I.
And I.
Okay. So my input to the system, V1 and I1. And I, V and I, or just V and I. Call V, because it's coming in the first, okay, call it R1 and call I equal to R2. Okay, now in here, I have, let's say, okay, now it depends on how many output I need. Suppose I have my output will be, let's say, VC1, okay, and IL2. So in this case, what's my matrix is going to be? What is the dimension of my matrix? So the Y1, take it VC1. The Y1 is going to be VC1, the voltage here. And Y2 equal to the current through this inductor.
Take one source at a time.
Okay. So this is going to be, okay. Now suppose I want to add, okay, the voltage here, VC2, across here. How many output I'm going to have?
The output.
3 outputs. And how many inputs?
2.
2
Two.
inputs. The input remain the same. So now I will have a matrix of
3 by 2.
no, a 3 by 2, exactly.
Yeah, because the number of rows has to be with the number of
Yeah, number of
output.
rows, they are number of the output, number of the columns, number of columns, number of inputs.
Yes, because it will be
Okay,
the inner.
is clear? And who asked me about the what the eyes? What are the-
Yes. Me, Doctor.
طيب.
Clear.
Okay. Now let's move. What we are going to do, we are going to okay, what we are going to do, we are going to start the process of, as I said, simplification of the blocks. But before that, let's, give some definitions. The blocks, we said, indicate a proportional relationship between, okay, two Laplace transform signals. Okay? Summing points. What's summing point? It's addition of signals.
ليكون عندها x هذه.
Yes. How about pickup points? You have a signal and you want to feed it to more than one place. I call it pickup point. The representation, those are the elements. Okay. This is basically the block diagram. It says a relationship between two Laplace transform signals, y and x. This is a summing point. I have 3 signals coming, A, C, and B, coming to this place, and the result will be, it's algebra. D equal to what? D, look, D is moving out, so D equal to?
Summation.
Yes, A1 minus C minus B. The pickup point, this is the representation. I have a signal and I would like to feed it into 3 places. Okay? Any question here? The block diagram reduction, what we are going to talk about, we would like to reduce a complicated system into a single system. Okay? Basically, the simplification is algebraic manipulation, and we are going to deal with single input, single output. The multi-input, multi-output will be done differently. So we are going to do things single input, single output. So to start the process, we can combine 2 blocks. Suppose I have x3. What's x3 in terms of x? x3 in terms of x2. What's x3 equal to? x3 in terms of x2.
Multiply
G
G2.
x2.
G2 times x2. But x2 in terms,
X1 also, Doctor.
which is equal to G2, G1, x1. So
Yes. Cascade.
I can reduce those two. I can combine those two into a single block. That would reduce the number of blocks which I have in the system. The order in here, it should be G2, G1, but it doesn't matter since we are talking about single input, single output. However, when we use multi-input, multi-output, the order will be very important. Why? Why the order is important?
Maybe if you want to go back,
No, not that. In multivariable system, if G1 and G2 are matrices, We know from algebra, matrices
Not commutative.
will not
commutative.
commute. In matrix
No.
algebra, for multivariable system,
Linear algebra.
G2 times G1 does not equal, not necessarily G1, G2. This is for multi-input. Multi-input. It is not always true. It could be true, but not always. So we have to be careful. But for single input, single output, if you put the G2, G1 or G1, G2, it doesn't make any difference. Okay? Well, I could use MATLAB to reduce the two systems. Okay, if you define the first system, let's say system 1 and system 2, then I will use the command system equals series of sys1, sys2. It will add them to you. It will combine them to you. MATLAB will combine them to you. Let's take an example. So suppose I have these two systems. What will be the combination of the two?
It will be ys equal s plus 1 all over 500 s squared times s plus 2 all rs.
Great. S over 500 S squared. Okay. In here I'll have S plus 1, S plus 2. Okay. MATLAB will do the job even nicely. It will expand. You define, okay, let me define, for example, I define this system, call it sys1. So it's going to be numerator is 1, denominator 500, 0, 0. Okay. And define sys, call it sysg. And then I have the other system, okay, numerator and 1 and 1, and then 1 and 2. The system, call it system H. Now combine them. Sys equals series of sys G, sys H. It will give you the result. So as I said, MATLAB will program the system for you. Now I can combine blocks if they are in parallel. Again, let me come in here. What's x2 equal in terms of x1?
Yeah, we have two bar. X1 will go with the G1 and G2.
G1.
Yeah, so we can take X1 as a common factor.
And in here I have plus or minus G2 x1, which is equal to G1 plus or minus G2 times x1.
Victor, you mean X2?
Reduce it
X2
into a
equal.
single block.
Left hand side is X2, Doctor.
كيف؟
Left hand side is X2.
Sorry, x2. This one, x2, yes. Thank you. Okay. Any question here? If I have, okay, if I have two blocks in parallel, I can reduce them into one. Again, MATLAB could do the job. And here I will have define system 1 and system 2 and put parallel. Okay. Now, let me take more concepts. Moving a point, summing point behind a block. That I have this summing point and I have a block in here. Now from here, what do I have? What we want to do, look, we want to keep the relationship between the signals the same, regardless the manipulation. For example, in here, what's x3 equal to? What's x3 equal to?
x1 plus or minus x2 multiplied by gs.
G times x1 plus or minus x2. What we try to do, I want to move the block before the summing point, like this one here. So let's see in here, what do I have? What's x3 equal to also? What's x3 equal to?
You can separate, you can break down the, it's a j.
No, just simply, okay. Abdurrahman,
Multiplied by 1.
so x3 equal to what?
x1 JS.
x1 plus, it's coming here, or minus g x2,
Yes.
which is equal to g x1 plus or minus x2. So basically, what we are trying to say in here, sometimes when I change the configuration, I can reduce the system easier. But what's important, I should keep the same relationship. For example, in here, there was no, I mean, the signal is multiplying, x2 is multiplying g. Okay, now I'm doing it in this way, so I have to keep, x2, it has to multiply g, so I duplicate my g into two places. The names, okay, to me, the names of, moving summing point, and later on we're going to have more, of this information. What's important, try to trace the signals, okay? The relationship between the signals should remain the same, regardless what you do.
دكتور
Yes.
I'm sorry, but why did we add more block?
Why do we have more blocks? Because look, I want, if I move this G before the block, before the summing point. Okay, if I move it before the summing point, well, I would like to multiply x by g, x1 by g, and x2 also by g. Okay, I'm moving my summing point and position it after the block. I'm moving this one and position it in here. At the same time, I would like to keep the relationship between x3 and x1 and x2 the same. So I have to, multiply x2 by g and x1 by g, and this is the only way I will do it.
Okay.
Okay. But that will, later on, we'll see, when we do these operations sometimes, it will simplify the entire block. It will simplify the entire attempt which we are trying to do. Okay? Let's, look into moving a pickup point ahead of a block.
دكتور معليش
تفضل.
بس لما نستعمل بلوك زيادة ما يعتبر يعني عيب.
ما بالعكس، ما هو انت ما يعني انت ما استعملت بلوك، يعني انت الحين look، يعني in real life you are not changing anything. This is mathematics. It is an algebra. Okay. It is an algebraic relationship. What we are trying to say, this relationship between x3, x1, x2, I can rewrite it in this way. Ultimately, if I want to find x3, do I change anything in here?
No.
No. So basically, think about it. You have, many simultaneous equations, and you are trying to, simplify by certain substitution. And that's basically what we are trying to do. It's an algebra. We are doing an algebraic relationship such that it will, you know, simplify the problem for me. I can solve it. Okay, by this process, but you know, of course, the problem in here, this is not unique way of doing it, and it's not systematic. We will come later on, maybe maybe next lecture or the lecture after. We will do the reduction, but by different method where it is, you know, there is a theory in there and it's systematic way. But this one, you know, it is a good method. You can use it. So we will be, you know, we'll be aware of this method and the other as well. Now, I am moving this pickup point. I'm putting it in here. So basically, this is x2. Okay. So if I move this point, I put it in this position. I'm feeding from here. Okay. So if I keep it without any modification, what is my output is going to be? What's my output?
x2 equal gs
It's going to
x1.
be, no, look, if I take from here, from this point only,
X1.
it's going to be x1.
Ah, okay.
So I have to multiply it by g to get x2.
It's kind of manipulation.
Yeah.
It's kind of manipulation.
Exactly. It is, look, it's algebra. To me, as I said, okay, I multiply, divide, later on we will go to see, we will divide.
For you know it by heart.
What you want to do, you want to keep the relationship the same. But, you know, change them so that they will simplify your process. Moving a pickup point behind the block, the other way around. That's basically, this is my pickup point. I want to put it in here. I will feed from this point. So x2 in terms of x1 is not going to change. But if I need the signal in here, I want to feed x1 again. If I put it in here, it means that I'm going to multiply by g. So to negate the effect of the g, I have to divide. Okay, I have to divide. So that from x1 to x1 will be remain the same. This is g multiplied by 1 over g, which is equal to?
Doctor.
Yes.
This is just a note. I'm thinking about the language here. Ahead and behind. It's sometimes like a kind of confusion, you know, behind the block, why it's not on the left of the block. Maybe before and after make more sense. What do you think?
It is again, it is, you know, I mean, look.
Language, but because behind usually is, you know.
Terminology. Yeah. There is no one way is right, one way is correct, one way and the other is wrong. Both, you know, I mean, it is used somehow if you go to the textbook of control system, the literature notation. But what you are saying, absolutely correct. I mean, after or before, it doesn't, you know, but it is. I mean, it has the same meaning. Okay. Now moving a summing point. Okay. Look, it is little bit, you know, what we are taking so much is little bit confusing, but once we start, you know, manipulating system, you will see it is very simple. Now I want the G will be after the summing point. So x3, what's x3 in here equal to? x3 equal to what?
x1 multiplied by g.
X1.
So g times x1 plus or minus x2. Okay. So x2 feed x3. Now, if I change in the interchange, I'm putting x2 through the block, through the summit point, sorry, and it's going to be multiplied by g. So I must take the, I must divide the signal in here. Because if you look at this one now, for this one, x3 equal to what? G times x1 plus or minus 1 over g x2, which is equal to gx1 plus or minus x2, which is exactly the same as the one before. So I'm dividing in here because, I am, I'm changing the path, and it should have the gain of the original one should have the gain of 1. When I change it in here to this side, I must divide by the gain such that the overall gain from x2 to x3 remain 1. Look, these maybe you don't use them a lot. This is what we continuously you will be using. Eliminating if I have a feedback loop. x1 summation point x2, and I'm feeding x2 back and comparing it to x1. I would like to reduce it into one block. The block will be in the numerator, you will have the direct gain from the input to the output. Anything in the way, you just multiply it over 1 plus or minus the loop gain. This is, we call it the loop gain. This is a loop, so all the elements in the loop, I call it loop gain, and I'll put it in here. So let me assume I have a negative feedback. This is only negative. Later on, we'll come to the positive. And let me assume this is E. I want to establish x2 in terms of x1. What is E equal to? What's E equal to?
x1 plus minus hsx2.
Let's take only minus this time.
Oh, minus, okay.
Okay. Minus
So
what?
it's x1 minus x2 hs.
Okay, x2. Now, what's x2 in terms of E?
E multiplied by G.
G multiplied by E.
And then you take x2 together, huh?
What I want, okay, the transfer function between x2 and x1. So I want to eliminate E. So let me eliminate E. So it's going to be G, okay, x1 minus h x2. Let me take x2 to the other side. So I will have x2 plus g h x2 equal to g x1. Can I solve for x2?
Yes.
Yes, you can solve.
It's going to be g over 1 plus gh x1. So I reduce this one into a single block. And if this is negative, we call negative feedback, I will have 1 plus the loop gain. If this is positive, this is going to be in here negative. So whatever the sign in here, invert it. And this we will use a lot. The entire course, basically, in the entire course, we will be using the feedback. Any question here? So now, let's do MATLAB. What do I have here? I have transfer function and a unity feedback. So the command which we will use, the system feedback equal feedback sys1, which is the one in here, and I'll put 1 for the, because unity feedback, and sign. The sign either, if it's negative feedback, we put minus. If it is positive, we put plus. If you don't put plus or minus, it will take the default to be negative feedback system, and that's basically what we will be using. Okay, if I have a block in here, I can, rather than the 1, I will write the system given by this diagram, and that will give me the, reduce the system into a single block. Any question? Okay, now let me come to,
معلش دكتور
تفضل.
مكتوب نيجاتيف باي ديفولت، كيف يعني باي ديفولت؟
يعني اذا انت نسيت وما حطيت ولا شيء هنا، كتبت فيدباك. اوكي اوكي sys1 اوكي 1 وسكرت، هو بياخذها. This is negative feedback. يعني you don't have to put it. If you don't put sign معناها انت عندك negative feedback. If sign, fine. This is, you know what's default?
Yes.
Okay. يعني الديفولت حقنا مثلا الكلاس حقنا يبدا الساعه بالعشرة.
No,
I don't have
positive.
okay, unless we change it. Okay.
You want
Now let me go back to what we have started at the beginning. We said I have this system. I would like to reduce it into a single block. Let me call it T. So I need find T of S, which is equal to C of S over R of S. Using the manipulation which we have said. Look, in here, there will be more than one way of doing the problem. But in any way, in any case, the final answer should be the same. But as I said, you have, you know, simultaneous, let's say, algebraic equations. Okay. Then you could eliminate one of the variable and then change to the other and so on. So there is no unique way of doing it. But the final answer remains the same. Okay. So now tell me, how do we start? Any suggestion?
We can start from the right.
Okay, from the right.
They are in parallel.
No, where, here?
Yes.
No, this is feedback.
Yeah.
But if you write it, but you know, you cannot do it directly. You write it in this way. Let me take, I'm adding 3 signals. Let me add 2 signals first. This is, let's say, V4. And the signal is coming from up, plus. Okay. So in here, look, what I did, rather than adding the 3 together, I add those 2. What do you call this? What do you call this one?
Negative feedback.
No. The process, you know, adding 2 at a time. What do you call it?
Parallel.
No, in algebra,
Associative.
Associative, isn't it? Yes, you are combining two at a time. So look, I'm combining the signal from here with V4, then I added to this signal. So I did not change anything, did I?
No.
Now, this
Doctor, excuse me, what did you do?
cave.
I didn't get what you exchanged.
I didn't get your question.
I say, what did you change, Doctor?
Say that again. يعني ما ادري بعد الكونكشن عندي مش واضح. Look.
Doctor, sorry, but the time is already up. Can you solve
it? Okay, Shabab. Okay, we will stop in here. We will stop in here. Basically, what I'm trying to say, we can put this as G3, 1 plus G3, H3. But anyway, we will stop in here and we will continue next time, inshallah. Okay.
يعطيك العافية.
حياكم الله.